Hello engineers, this is Zubair. In this video, we will see about the design of dog-legged staircase. Okay, so here we have different types of staircase like open well staircase, folded staircase and dog-leg staircase, circular staircase. Okay, so generally in residential structure we are using this type of dog-legged staircase. Okay, so let's take example over here. This is the staircase plan. Okay, so floor height is 3 meter and thread size is 250 mm. Riser is thread size is 250 mm and riser is 150 mm. Okay, so these are the standards. 250 mm and 150 mm. Okay, so here we are using M20 grade of concrete and Fe 415. The floor finish is according to the material. Here we are taking 0.9 kilonewton per meter square. The live load is 3 kilonewton per meter square. This is for staircase for residential structure. Okay, we can use IS 875 part 2 for live load. Okay, so width of the supporting beam is 230 mm. Here we can find the height of each flight. This 3 by 2 height of the floor divided by 2 will get the height of each flight 1.5 meter. Now we'll see this later. Now number of riser is equals to 1.5 is the height of each flight, height of mid landing divided by 0.15. This is the riser. We'll get 10 number of risers. Okay, now number of threads is equals to 10 minus 1 is equals to 9. We'll get the number of threads 9. Okay, and width of the thread is 250 mm. Now we can find the length of the number of threads into width of the thread. 9 into 250 will get the length 2.250. Now here width of the stair is 1.26. And width of the landing is 1 meter over here. It's according to the usage. Okay, 1.1 meter is the width of the landing. So here now we need to find the effective horizontal span. Here 2.25 meter. This one 2.25 meter going, 2.25 meter plus this is the width of the landing. Here we are considering the 1.6 meter. You can use according to your plan. Here we are considering the 1.6 meter width of the landing. This is the width of the landing. Okay, now plus 0.23 width of the supporting beam. 0.23 divided by 2 will get the effective horizontal span. Will get 3.625 meter. Okay, now assume thickness of waste slab. We'll assume 40 mm per meter. Okay, we'll assume thickness of waste slab is 40 mm per meter. Okay, now if overall depth is equals to 40, this 40 is for per meter, 40 into this span, effective span 3.625 will get the 145 mm. Will provide 150 mm overall depth. 150 mm is what overall depth. Okay, now we'll find the effective depth of the waste slab. Now D is equals to 150 minus this die of bar. We are using over here 10 mm die of bar and 20 mm 10 mm die of bar and 20 mm clear cover. We are assuming over here. Okay, so 150 minus 10 divided by 2 and minus 20. See here, this is the slab, this is overall depth. We need to find effective depth. Okay, so this is how much? 10. Okay, 10. This one we are finding. This 20, half of 10 will get the effective depth of the waste slab. Okay, we'll get 125 mm. Okay, 125 mm. So now dead load self weight of the waste slab will get 0.15 into density of concrete for 3.75 kilonewton per meter square. Finishes, okay, it's depend on the material, okay. Here we'll get the 0.275 kilonewton per meter square. If you calculate this, if you add these two, we'll get the 4.025 kilonewton per meter square. Okay, this dead load is for waste slab. Okay, this dead load is for what? Waste slab. Now, load on horizontal portion. We need to find what? Load on horizontal portion. W is equals to root under root R square, means riser square plus thread square divided by T, thread. Now we'll get this load 4.025 under root 150 square plus 250 square divided by 250. We'll get what? A load on horizontal portion 4.69 kilonewton per meter square. Okay. Now dead load of step. Now we need to find what? Dead load of step is equals to riser divided by 2 into density. Riser is how much? 150, means 0.15 divided by 2 into density of concrete. We'll get 1.875 kilonewton per meter square. This is the dead load of steps. Dead load of what? Steps. This is the dead load of waste slab. This is the dead load of steps. This is the dead load of horizontal portion. Okay. Now, top finishes we will consider 0.5 kilonewton per meter square. This is also depending on the material. Okay. Now live load we are considering 3 kilonewton per meter square. Now total load per meter. Total load on what waste slab on per meter 4.69, this load, horizontal load, plus 1.875, this what step load, plus 0.5 is the floor finish, and plus live load into 1 for per meter. We'll get 10.06 kilonewton per meter. Okay. Now you can read this note. The W means load on the landing portion. The load on the landing portion will be 10 point this total load minus 1.875, this step loads. Okay, because this step loads will not act on the landing, that's why we are deducting this load. Okay, now factored load will be 1.5 into 10.06, we'll get 15.09 kilonewton per meter. Okay, now we'll find the factored moment. Mu is equals to WL square by 8. We'll get moment is 24.78 kilonewton meter. Now we need to find the deflect for effective depth. Okay, check for effective depth. D is equals to Mu divided by FCK into B. Now put the values 24.78 into 10 raised to the power 6 divided by 0.13 for Fe415, 20 into 1000. We'll get the depth is 94.75. We'll make it 95 mm. We have provided depth is 125. Effective depth is 125. You can see here the provided effective depth is 125. You can the limit of the effective depth is 95 mm. Okay. Now it is safe in depth. Okay. The effective depth is safe and safe. Okay. Now main reinforcement. You can use this formula. M is equals to 0.87 Fy AST into D and 1 minus AST Fy divided by B into D FCK. Put the all values in this formula and make it calculate, and you will get the AST value. You will get the what? AST value for this 611 mm square for per meter. For per meter. I will use 12 mm die of bar. I will use for this AST 12 mm die of bar at 160 mm center to center. You can use 150 mm, you can use 175 mm. Okay, center to center as main reinforcement. As a what? Main reinforcement. Now distribution steel, distribution reinforcement. We need to provide 0.12% of cross section. 0.12% of cross section. So 0.0012 into 1000 into 150, 1000 per meter into thickness overall depth. Okay, now we'll get 180 mm square per meter. Here we can use 8 mm die of bar at 200 mm center to center. Okay, 200 mm center to center. This is about the calculation. We'll get the distribution steel, we'll get the main steel. We can draw the cross section of this staircase. You can use this this diagram, or else we'll see another diagram over here. Okay, now These are the main steel. These are the 12 mm die of bar, and 160 mm center to center we have taken, and this distribution steel 8 mm 200 mm center to center we are using. Okay, so this is about the staircase. This is all about the staircase, and in next videos we will see about the design of open well staircase and design of folded staircase. Okay, thank you very much.